Okay, good afternoon, everyone. So we still have 3 weeks of class, and those 3 weeks will be, we will learn a lot in those 3 weeks. And I know that you are concerned about, you're not concerned, but I mean, you're wondering about your exam. I'm working on it. If I'm lucky, definitely by Thursday, I hope to be done and your grade will be out. Any questions before we start? Okay, so today we're gonna keep working on the exponential function. First, I remind you what we know so far, and then what we will be learning. So we're working on 3.1, 3.2 simultaneously. It's the same ideas. So first, what we know. What we know is that, so exponential.
That means the fools are ours.
Okay. Do you know when the test will be entered? By Thursday, I'm hoping, Amanda. By Thursday. All right. So exponential function. First, let us recall that the formula for exponential is f of x equal a times b to the x. A is the initial value, means the value at 0, and b is what we call the growth factor. And then we studied when do they arise. So we did the following problem. So when do exponential arise? So with that, I'm trying to recall what we know so far. When do exponential function arise? It means what kind of real life problem will bring up a formula like this? Arise. All right? Okay. Usually they arise when the following scenario happens. Suppose if something, a quantity like money or population, grow by the same percent as we've seen, that's when they arise. So every year they grow by the same percent, 2%, 3%, whatever. That's when the formula that will govern is an exponential. So we saw the following scenario in class. Okay. So suppose like we have, you put money in the bank. So let's suppose at t equal to 0, Joe put, let us say, $5,000 in the bank. Okay. And let us say the bank give an interest. So, and suppose that the money grow by, let us say, 2% per year. It means that's the interest that the money gives. Okay, that's a typical scenario where we use exponential. So you put 5,000 and your money grow by 2%. And the question is, suppose we call f of t. And let us say this rate continue. So the amount after t years. Okay, that's a typical exponential scenario. So what is f of t? Okay, who can put the formula on chat for me? So you start with 5,000, your money grow by 2% a year. It means if you want to know how much you will have after t years, assuming the same rate continue. I mean, there is no change at all. So what's the formula that gives you the amount after t years? Put it on chat quickly. Can you guys hear me? So what's the formula? 5,000 is the initial amount. It will grow by 2%, right? So it means the growth rate, the rate, not the factor, is 2%. It means every year we have 2% extra, which is 2 over 100, which is 0.02. It means the formula is that every year we multiply by 1.02. And that's really where the exponential happens. And graphically, what's really going on? So we start with 5,000. 1 year into, after 1 year, the money grew by, that's how much it grew, 2% of the 5,000. which is like 100. Okay. And extra, so now we have 5,100 in the bank after 1 year. Another year, we grew by another. Right now, we grew by the 2% of a larger amount, 5,100, which is, if we do the math, we get 102. So now here we grew by 100 the first year. The second year, the money grew by 102. So it's definitely not a linear growth, because linear, we grow by the same amount. And the graph will be something like that of the exponential. Okay, so it's definitely not linear, because in a linear growth, things grow by the same amount. When they grow by the same percent, it's very different, because we start at 5,000, 2% means we increase by 100. So we are 5,100, then we're getting an interest over a larger amount. So interest, the 2% over the 5,100, which is 102. So every year we're getting interest more than the year before. So that's really was the typical scenario of an exponential. Now, another scenario, we took it when we have a decay. So I will summarize it quickly. Then we'll introduce the new ideas. So the second scenario was the following scenario. Suppose things decay. So I take a population because I don't want money to decay. Suppose at t equal to 0, population in a certain fictional town is 5,000, let us say, and it decreases by, let us say, 6% per year. It's going down. So what's the formula for the population? Years. Okay. So let us see what the formula here is. So f of t equal. Now, it decreased by 6%. It means every year it loses 6%. It loses 6%. So the growth factor, which is the b, sorry, my apology, it's a minus, because we have a negative growth. Minus is crucial. So the growth factor, the b, is 1 minus the 0.06. It means 0.94. Means every year, 6% gone, 94% of the population remain. That's really what the 94%. So f of t is the 5,000 times the b, not the rate, the b to the power t. So that's really the other scenario we saw, whether it's increased by the same percent or decreased. And again, the graph will go like that. We start with 5,000. After 1 year, we're going to go down. And we go down by the 6% of the 5,000. The 6%, if we pick up our calculator, we go down by 300. So after 1 year, we have 4,700. That's the population after 1 year. That's the decrease. Another year, now we are at 5,700. We're going to decrease by 6% of the 4,700 by a lesser amount. So decrease by the lesser amount. So we're going to go a little bit less than that, something like this. And if you pick up your calculator, and we get 282 after 1 year. So the graph is going to look concave up this picture. All right, so that's what we know so far as exponential is concerned. The formula for it and why we need it, because it represents a decay, which could represent a growth, positive or negative by the same percent. It's definitely not linear. Today, what we're going to do is the following. Let us say we have the following.
Sorry, can you move it over just a tiny bit?
Tiny bit?
Yeah, like
That's
to the, or over towards the graph. Okay, there.
Thank you. All right. Now, what we're going to do today is the following. Let us say I have a population. And I know that it's increasing or decreasing by the same percent. But I actually don't know the percent at all. I don't know by how much. But I have 2 data points. Let us say I know the population, let us say we know it initially, And we know the population after, let us say, 2 years, but I don't know the 6%. I don't know that. So I have 2 data points. And the question is, how can I find a formula for the population? So problem number 2, what we're gonna look at is something like that. I have an exponential function, but the only thing I know are 2 data points. Means I know 2 points on the graph. The question is, how can I find a formula for the exponential function? That's what we are going to be doing today. All right. So before I do that, I like to mention a little bit about property of the exponent, because we're going to use them, and multiplying and dividing exponent. So it's a little bit of algebra. I will spend 5 minutes on it. So multiplying and dividing exponent, because I'm going to need that. Okay, what do I mean by that? I will ask you a very simple question, and before we write the rule. Suppose I give you 2 to the power 3, and I multiply it by 2 to the power 4. So it's the same base, but the powers are different. This will give me 2 to which power? Back to you, it's not a hard question. 2 to the power 7, exactly, because think about it. 2 to the power 3, it means I have how many 2s? 2 of them, 3 of them. 2 to the power 4, I have 1, 2, 3, 4. I have 4 of them. So basically, how many 2s I have? I have 3 plus 4, which give me 7. So the general rule, if you have a to any power m, and you multiply it by a to the n plus n, you basically add the power. And if you ever forget the rule, just make up numbers and ask yourself, what's happening if I multiply 2 to the 3 times 2 to the power 4? How many 2s do I have? Now, suppose I give you 2 to the power, let us say 7 or 8, whatever, 7. And I divide it by, let us say 2 to the power 2. Okay. I want you to do it along the same line. You get 2 to which power? 5. Do you agree with Jessica? Because again, if you ever forget, try to make sense out of it. I have 7 2s. I divide them by 2 2s. So I have like 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I divide them by 2 times 2. 2 will go, and I will be left with the 5. Where is the 5 coming from? It's the 7. You take away the 2. So another property of the exponent, if you take a to the n, what you do with the power is you subtract them, n minus n. Okay, so just like a reminder of multiplying and dividing power. So for example, very quickly, if I have, I will write 3, suppose I have a number, b. I'm gonna call it b, for example. B to the power 4 over b squared will give me b to which power? Very quickly, very simple. B to the power 2, okay? If I have b to the power 7 over again b to the power 3. 7 b's, 3 b's, I will have to the power 4. All right, so a quick review with what happened to the power. Right. Now I'll go back to my problem that I talked about, which is the following. I have an exponential function. I have 2 data points. What's the formula that will fit? And that's really our main goal for today's lecture. So here we are. Okay, so how to find? How to find a formula means a rule for an exponential function from 2 data points. If I give you 2 points, how to find it? Okay, so how to find a formula from 2 data points. before again I stop, let me say, if you have a function, because I have to relate it always to what we did with linear. If you had a function, and if you know that the function is linear, it means the graph is a line. And if I give you 2 points on the line, we know how to find a formula for the line. So we find the slope. So that's the equation of the line. We find m, we find the slope, and then we find b. So if you have a line and you have 2 points, we use this formula to find the equation of the line. Now we're going to do the same, but my function is exponential, not linear. So it's basically the same idea. So here's my problem. The problem is, let me set it up correctly. So example number 1. We have an exponential function. So let f of x be an exponential function. Exponential function, sorry. Some value of f are given to you. Find some values of f, and I will explain every word in a minute, are given below. Find a formula for f. For f. So write this down, and then every word will be explained clearly. So this is x, this is f of x, and 0, 3, 2, 12. All right, so what I'm talking about. I'm telling you, f is exponential function. Exponential means immediately for you that the form is a times b to the x. So exponential is not linear, it's not mx plus b, that's the form, a times b to the x. In this table, I'm giving you 2 values for f. I'm telling you what's f at 0, what's f at 12. And I'm asking you to find a formula. It means you need to find the a and the b. Okay? So graphically, that's the picture for you. That's what's happening graphically. You have a function. At 0, it takes the value 3. At 2, it takes the value 12. So my scale is not very good, but it takes the value 12. Exponential, it means my function is not linear, it's actually curving, and that's increasing. That's my function. That's the graph. My question is, I want a formula that will fit the graph. So how we are going to do this type of problems? The way we think about it is that I have 2 unknowns, a and b, like I had 2 unknowns for the linear, m and b. I have 2 unknowns. I need to find them. But here, they gave me 2 data points. The data point will give me a relationship between a and b. So let's explore the data point. What does this tell me? The first tells me that at 0, that's 0, the output is 3. So this tells me that if I plug in x for 0, sorry, 0 for x in the formula, right here, I should get a 3. So this b to the 0 is 1. This will give me a of the back immediately. And we knew that because a is always the value at 0. So if I have 0, I have that. Now the other data point is f of 2 is equal to 12. Let's see what does this mean. I plug in 2 in the expression of the function. It means if I take a times b, f of 2, it means if I plug in 2 for x, I should get 12. That's how we read this. But I know what b is. But I know that a is equal to 3. It means if I have 3 times b squared is equal to 12. So my goal now is really to find the b. So this will tell me that b squared equal. I divide by 3 both. 12 into 3 will give me b squared equal to 4. It means my b is the square root of 4 my b is equal to 2. It means my function has the form 3 times 2 to the x. This is 3 times multiplied, okay? Or if you want, 3 times 2 to the x. So that's the formula for the exponential function that fits this data. Now, I want to check. Now watch carefully how I check. I want to check that my formula makes sense. What does it mean to check? It means I want to check that the formula I gave you fit into this data. It means I want to show you that the formula I gave you takes 0 to 3 and 2 to 12. So let me check. According to my formula, f of 0 is 3 times 2 to the 0, it's 3. So this is satisfied. At 2, according to my formula, this should be 3 times 2 squared. 3 times 4 equal 12. Absolutely correct. It takes 2 to 12. So my function fits the data. So that's really the idea. So now I have 2 data points. My question is to find the formula that fits the exponential function that fits the data. And that's one way to do it. I'm going to give you another example, but this time I'm going to give you a little bit of time for you to figure it out, and then I will take over. So the same type of problems, but this time you will have to do it for me. So the same question as in the previous example, but now for the following data. So same example number 2. Same question as before, but for the following data, for the following values. Okay, so my values are, this is x, this is f of x. I want the function to take 0 to 100, and I want it to take 4 to 90. Okay. So it's exponential. It's not, it's exponential. So graphically, I like always to have a picture. This is decreasing. It's important to know that because, so at 0, I am at 100. And at 4, I am at 90. So, sorry, 90 is right here. So at 4, I am at 90. So this is my function. It's go like that. So this point here is 490. It keeps decreasing. Question is, find a formula for f. Now, because it's exponential, as I told you, it means this is the formula that governs the problem. And your job is to find A and B. Okay, I'll give you 2 minutes to tell me the answers and start putting them on chat the minute you find them. So each one of you is responsible to give me the A and the B. Anybody is coming up with anything? Nobody yet? Okay, let's do it together then. See what you guys come up. F of 0 equal 100. Okay, Leia gave me 3.71 for what? Remember, you have to find A and B. 3.71 is for what? For B? Oh, I don't know. Anybody else getting the same answer? All right, let's do it slowly. F of 0 is 100. What does this mean? It means that if I plug in 0 for x in this formula, I should get 100. So, and this will give me A of the bag immediately. Okay, 100. Now the B, because I need to find both of them. And I usually have 2 data points because I have 2 unknowns. Now I want to find B. I use the second data point. I say, all right, how do we read that? F of 4 equal 90. It means if I plug in 4 for x, watch very carefully, I should get 90. If I plug in 4 for x, I should get 90. But A, so now I'm going to use, I really don't want to solve for B, but A is 100. So it means 100 times B to the 4 equal 90. I need to solve for B. That's what I want, to solve for B. So I need actually a formula that will fit this exponential. To be able to do that, I need to divide by 100, both sides. So this will give me B to the power 4 equal 90 over 100. It means B, if I divide 90 over 100, I get 0.9. That's B to the power 4 though. If I want B, I need the 4th root. Be very careful. I have B to the power 4, so I need B, I need the 4th root of 0.9. Now, I pick up my calculator and I compute the 4th root. So I don't know where my calculator is. Sorry. All right, so we're gonna compute the 4th root. One way to compute the 4th root is to take 0.9 to the power 1/4. So I'm getting 0.974. So if you guys are doing it, 0.974. So what's the formula now for f of x? It means f of x is going to be equal to 100 times, so that's the b to the power x. Okay, and that's really the b is 0.974. Now let me check if my answer is correct. Let me check. What do I mean by check? This is an exponential because it has the form a times b to the x. Check, it means this function I found, does it take 0 to 100? And does it take 4 to 90? I mean, does it really fit the data that I want? So, okay, I say, all right, f of 0 is 100. That's the easy part. I don't have issue with that. Now, basically, I'm checking, is my number here fine? So I'll compute f of 4. And f of 4 should give me 90 almost. And if it doesn't give me 90 using this formula, it means I'm messing up. So this is going to be 100 times 0.97 to the power 4. I'm just checking that my math makes sense. So now I compute that. I may be off by a little bit because I rounded. So let me put it here. When I took 0.9 to the power 4, I rounded a little bit. So I may be off by some. So 0.974 to the power 4, I got 89.99, which is pretty much almost 90. So this is 89.9986, which is almost 90. I'm a little bit off because of the rounding error. Okay, so my function is all right. All right, so this is situation where if I have some data, 2 points, how can I find the formula for the exponential? Now, the third example will be the following. Example 1, example 2, I gave you A for free because I told you what happened at x equal to 0. Now, I don't have to do that. I can, instead of giving 0, I can change, I tell you what does the function do for x equal to 1, for example. I can come up with a number. So if I don't have 0, it means if I don't have the initial value, I have 2 other data points. How can I find the formula for my exponential? So example number 3 will actually be this type of problem. So example number 3, it's the same thing. I need a formula for my exponential function. So example number 3. So find a formula. So the same question as before, f of x exponential. Okay, and we have the following data. X f of x. So f exponential, find a formula for f. Find formula for f. For f. Okay, so I'm going to give you a bunch of data. I tell you f takes 1 to 3. So I don't give you 0, and it's taking 3 to 12. It's like in linear function. We don't always have to give you what happened at x equal to 0. We can give you any 2 data points. And the question is find a formula. So graphically, I have the following picture. X is 1, this is 3. So that's a point. 1, 3. Another point is 3. So 1, 2, that's a 3. 12 up here. That's another point. That's 3, 12. My function is exponential. It means it curves. It's not a straight line. It's curving. My question is to find a formula. All right. So this is a little bit different from the other problem because I don't have a. I don't have a. So the minute I read this exponential, means that the formula that should guide me is f is a times b to the x. And now what I need to find is, I need to compute a and b. So the question is, we need to find a and b. So let's listen very carefully how we're going to do this type of problem. All right. I say, all right, I have 2 unknowns, a and b. To be able to find them, I actually need 2 equations that relate a and b. And that's where my data point come into the picture. I say, okay, my function f takes 1 to 3. What does this mean? Mean that if I plug in 1 for x, I should get, I should get 3. If I plug in 1 for x, I should get 3. Now I have another data point. My function takes 3 to 12. So notice, in this case, I cannot get a. Like in the previous example, I gave you a because this was 0. This problem, I cannot pull a. So that's really the difference between this scenario and the previous scenario. Now, f of 3 is 12. It means that if I plug in 3 for x, so this is my x here. If I put in 3, my output is 12. So now the way I look at this problem is I have 2 equations that relates a and b. That's really what the problem is. And the idea is, well, we're going to solve for them. And there are different ways to do this problem. There is not really only one way. There are different ways to do this problem. And we will learn one of them. But that's the way you look at it. I have 2 equations that relate a and b. I need to solve for each one of them. All right. One way we can do this problem, one way, I did not say that's the only way, is the following. It looks like weird, but then you will understand why it's actually easy. I'm going to divide the 2 equations by each other. Let's see how I'm going to divide them. I'm going to take b to the highest power here, divided by a times b. So I'm going to take the ratio. And I say, okay, this should be equal to, according to my equation, 12 divided by 3. What's the benefit of doing this? That's the only trick you have to learn to solve. What's the benefit? Can anybody tell me what could be the benefit of doing this? I have two unknowns, so usually the idea is to get rid of one of them. What's the benefit?
Is it solving for B?
Yeah, why this will help me solve for B?
Because you're taking the problem, the f of 3, and then you're pretty much dividing it by the f of 1, so that will equal to 4.
But why here I can solve for B? What can I do at this stage?
Subtract?
No, not yet, not yet.
Oh.
How can I isolate the B's? And what's the benefit? Why we divide? What can we get rid of when we divide?
Oh, A.
We can get rid of A. That's the heart of the idea. The reason we can divide because we can get rid of the A. So A over A, we can simplify it, and then I will be left with B to the 3 over B is equal to 4. So the trick we use by dividing those two equations, that it will allow me to basically get rid of the A. Now, as we saw a minute ago, B3 over B is B squared equal to 4. It means my B is to 2. Now I got the B. All right, so it's a little bit different because in the previous problem, I had the A that I was able to get the B. This time I don't have it. That's why I was able to solve for B. Now I still need A. Now we need to find A. Okay. To find A, I said, I have two equations that A and B should satisfy. This one and this one. I pick any one you want. Pick this one, for example, and I say, okay, A and B are related by this equation. If I know the B, I should be able to use to get the A. All right, so now let's do that. So this is the equation I'm going to use. I say, I know that A times B is equal to 3. That's f of 1 equal to 3. But B is 2. So I will have A times 2 equal to 3. It means my A is 3/2. Now I have my A and then B. It means I have the formula for the function. So my function f of x equal 3/2 times 2 to the power x. I put it in parentheses to emphasize that this is 2 is the one which is raised to the power x. And that's the formula for my function. And now I check. What do I mean by I check? It means I ask myself, this is the formula, which is exponential. It's A times B to the x. Does this formula take 1 to 3 and 3 to 12? If it doesn't, I'm doing something not correct. So that's how I'm checking. Okay, so I'm going to evaluate it at 1, and I should get 3. Okay, let's see what I get here. 2 to the power 1 is equal to 3. So this is satisfied. Then at 3, according, it should take me to 12. Let's see what it does at 3. 3 over 2 times 2 to the power 3. It means 3 over 2 times 8, 24 over 2, which is 12. Check. It means I'm doing it correctly. It means this exponential function does satisfy the data. It takes 1 to 3 and 3 to 12. Okay. I'll do one more problem along those lines, but I really would like you to do it also yourself. Okay, now so let us same example for the following value. So same as before, same questions, but for the given value of f. Okay. Same question, but for the given value. So my values are x and f of x. And I wanted to do the following. I want the function that to take 2 to 4 and to take 5 to 13.5. And the question is, find the formula for the exponential. So graphically, I want the function to take 2 to 4. This is 4, that's a point, and 5 to 13.5. So that's an increasing, that's my function. And find the formula, find the exponential function that satisfies the two given conditions. Okay, so here f of x equal a times b to the x. My question is find a and b. That's what we really have to do. Right. Would you guys like to work on it a little bit? Okay, I'll give you a little bit, but please work on it. I'm going to ask one of you to lead the lecture, to lead me, but I don't want to do it by myself. So one of you is going to be asked to lead it, I mean, to guide us. If any of you find anything, please put it on chat. If you find one of them, if you find B, let me know. Any of them. Doesn't have to be both. Okay? Anybody agree? I don't know the answers. Anybody agree with the B that one of your classmates gave us? Okay. So okay, so I'm going to pick one of you and I'm going to ask them very nicely to lead me, tell me what to do. And all right, let me pick somebody in the middle. Let us say Brianna. Brianna, are you ready? Brianna, I move on if the student doesn't answer.
Yeah, I'm here.
Okay, can you do it?
Yeah, so what I did was I started off by writing a times b squared equals 4. And then underneath that, I did a times b to the 5th equals 13.5.
Mm-hmm.
And then the next thing I did was a times b to the 5th
Yeah.
divided by a times b to the 2nd. And then it'd be the 13.5 over 4
What's the benefit of doing this?
to find the b.
Yeah, because now we can simplify. It's a common factor in the numerator denominator, we can factor it. And this would give me what?
And then I got b to the third equals 3.375.
The third, because I have b5 over b squared, we basically subtract the powers. All right, and now what's the b?
So it'd be b to the third equals 3.375, and then you like square it by the 3.
What do you call that?
I honestly don't remember.
I know. Cubic
But I
root.
know what I'm
I
trying
know,
to say.
I know. Cubic,
That.
cubic.
Oh, cubic root. And then I got b equals 1.125.
I think 1.5, when I did it, is the more correct answer.
Okay.
So try it on your calculator again. So I'm gonna do it myself. So basically it's 13.5 divided by 4 cubic root. I know some of you figure out on their calculator. For me, I actually take it to the power a third. So I don't have to click anything. Well, that's what's the cubic root. It's to the power a third. And then I enter, I got 1.5. So check what you did wrong on your calculator, because that's important to do things correctly.
Yeah, I got it. I got 1.5 now.
Yeah, that's the B. Now, how can I find the A?
And then I just plugged in, I just did the A times the 1.5.
Which equation did you use? We have
I
to
did
use one of them.
And then times the 1.5 squared equals 4.
Right. So we're going to use this equation, and we get A B squared equal to 4. That's the equation we have that relate A and B. But B is the 1.5. It means A times 1.5 squared equal to 4. Now I need to solve for A. So now you can multiply 1.5 by itself. So if you multiply this by itself, so 1.5 squared, that's give me 2.25 equal to 4. And now we solve for A by dividing by 2.25. And I don't know how much you guys are getting. I'm getting 1.7. Let's get at least 78. Okay, just round it up at the second decimal place. So this will give me that my function has the form 1.78 times 1.5 to the power x. Okay, and then you can check. You can check your answer the same way I've been checking over and over. Okay, so it's not actually hard. It's basically, once we know the algorithm, it's fairly simple. So the last example along those lines, before I move on to linear versus exponential, is the following problem. Let me go back to a population issue. So my last example is, suppose scientists are studying population of a certain species, and they don't know how fast it's growing, by what percent, but they can actually check the numbers. So they realize the following, that at equal to 0, the population of whatever you want, the population is, let us say, 5,000. It could be turtles, it could be rats, that's the population, okay? And they check the population, let us say, after 4 years, so at equal to 4, the population is declining, so we have a certain population, and the population is 2048. Okay. And then f of t, let f of t be the population after t years. Now, we're going to assume that the population, so it's decreasing because it was 5,000 down to 2048. So assume that the population is decreasing exponentially. It means by the same percent, basically, is decreasing exponentially. Question number 1 is, The first question is find a formula for the population. We're going to first find the formula. And the second question is going to be, okay, once you find the formula, what we're going to do is find the growth rate. It means this function by what percent it is changing. Right? So basically we have the following scenario. This is my T, that's my population. It started at 5,000. And after 4 years, it's down to 2048. So it's really, I mean, almost it's going down rapidly. But it's exponential. It means the graph is going like this. It's not linear. That's the graph of the population. And now the question is, we're going to find a formula. So since I'm telling you it's exponential, it means it's governed by the relationship A times B to the T. And my question is to find A and B. All right. Again, I have two data points. I have the initial value, T equal to 0. So we know that initially the population was 5,000. So this tells me that A, because I gave you the initial value, now is 5,000. So I know. For B, I need the other data point. So after 4 years, my population is 2048. Okay. So it means that if I take A times B to the power 4, because it's 4, is 2048. But I know what my A is. It means if I take 5,000 times B to the power 4 is 2048. Now I need to go after my B. So B to the power 4 is going to be 2048 divided by 5,000. And I can compute this number, and then I'm going to take it to the power 4. So let's give me B to the power 4. Sorry. B is the fourth root of this number. So I have now the fourth root. Again, I pick up my calculator and I take. So it's 2048. 2048 divided by 5,000. I'm going to take it to the power 1/4. Okay, I'm getting 0.8. So we know that things are decreasing, so the B has to be less than 1. So finally, f of t equal, the formula for the population is initial times 0.8 to the power t. That's the formula for the population. Okay, so now I don't know. So far, I have two data points. I use them to find the formula for the population. Now, question number 2 is, what is the growth rate of the population? So question number 2 is, find the growth rate. Okay. It means every year, the population is decreasing by what percent? Now that I know the formula, I want the rate. By what percent is the population decreasing? Again, put your answers on chat before we do them. I want more answers. So now we have, this is the formula. It means here, the growth factor is 0.8, right? Which is, that's the growth factor, which is 0.8. I want the growth rate. It means 0.8 tells me that every year the population is 80% of the year before it. I want by how much, by which rate it decreases. Now let us remember the relationship, and you guys have the correct answer now. We know that 1 plus the growth rate equal to 0.8. So the growth rate is how far is the growth factor from 1. So my growth rate is 0.8 minus 1, which is minus 0.2. Now that's the correct answer. It means minus 20%. The minus we expected because the population is decreasing. So there is a negative growth by 20%. It means every year the population is decreasing by 20%. So 80% is left. So the growth factor tells you how much is left. And the 20% tells you how much left. So every year, 20% of the population is leaving and 80% is left. So it's a scenario where I have data, but I don't know the percent. So once I have the data, I give me enough information to find the B, which is the growth factor. Once I know the growth factor, I can go immediately after the rate and understand the problem. Okay, so that's really the so exponential function. That's how we find the formula for it. All right. Right now, what we're going to do is the following. We're gonna go back and find the difference one more time between linear and exponential in a way. In other words, if I have a function and I give you a bunch of values, you know, and I tell you, can the function be linear? Okay, so you don't have to write. I'm gonna ask you a very, suppose I give you a bunch of values. Suppose I tell you this is x, this is f of x. 1, 2, 3, okay? And I give a bunch of numbers, very easy numbers. I'm gonna put 3, 9. And I ask you, can this function be linear? What would you say? Yes or no? I have one answer. Do you agree with the answer on? Absolutely, because I'm gonna go there again. As we're increasing by 1, my output is increasing by the same amount. That's linearity. So the question is, what if I have a table? 1, 2, 3, and I put a bunch of numbers. How would I know whether this data can be fit into an exponential function? Yes or not? Okay, so I'm gonna do the following. Now we're gonna compare linear versus exponential. So we have two functions. We studied linear, exponential. We're gonna start comparing them. So linear, which is I think it's 3.2, linear versus exponential. Okay, very quickly, we're gonna remind you the linear, that's the one we totally understand, and then I'm gonna talk about the exponential. So first, let us recall the linear. Recall because we should know that by now. Let's recall the linear. Now does the linear work? So suppose I have a function f of x equal 5x plus 4. That's a typical linear. The slope is 5 and b is 4. And let us remember, how does linear work? If this is x, this is f of x. That's linearity. 0, 1, 2, 3. And how does the output work? At 0, it's 4. At 1, it's 4 plus 5, which is a 9. And the way f of x works like this. When x is increasing by 1, f of x, the y value, increases by 5, which is the slope. That's really what's happening for linearity. Okay, when x increases by another 1, this is going to be 4 plus 2 5s. 4 plus 5 times 2. So we already added 1 5, so it's going to be basically 14. It means we're adding a 5. Every time we add a 5, we add a 1, we add a 5, which is the slope, which is give me whatever, 19. Okay. So graphically, the linearity is, that's the picture for linear. At x equal to 0, that's the b. And then as we go by 1, my output go by 5, exactly 5. Another one, exactly 5. So another one, exactly 5. So that's linearity. Okay, so when x increases by 1, so that's what x increases by 1, the y value increases by 5, which is the slope. Okay, so if you have a table, that's really the behavior of the linear function. So in general, we have the following. So in general, if f of x is a linear function, mx plus b, then when x increases by 1, the y value increases by m, which is the slope. If the slope positive, the y value increases. If the slope is negative, the y value decreases. So graphically, we start at b. Every time we go by 1, increases by m the y value. Another one, another m. That's linearity. Now exponential. How does exponential behave? So this is the part we somehow know. Now I'm going to talk about exponential. If you have a table of value, what's going on in a table? Okay, so now let's look carefully at the exponential. It means when we increase the input by 1, what does the exponential behave? So I'll elaborate by an example. Suppose f of x is 4 times 5 to the x. I picked the same number on purpose. In the previous one, 5 was the slope. Here, 5 is the growth factor. So now this is the growth factor is 5. And I want to study how this function changes when x increases by 1. So this is my x, and this is my f of x. And my goal is to see the following. When the x value increases by 1, what happened to the y values? In linear, we add 5. In this here, when x increases by 1, we added 5 to the y value. Now let's watch what's going to happen here. If x is 0, that's 4 times 5 to the 0, which is a 4. After 1, what is the output at 1? It's 4 times 5. We multiplied by 5. It means from here to here, we are multiplying by 5. And the question is, does this pattern continue? Suppose x increases by 1 again. What is f of x? It's 4 times 5 squared, which is basically 4 times 5 times another 5. It means from here to here, we also multiplied by 5. And the word growth factor is coming from the fact that we're multiplying every time when x increases by 1, my y value is always multiplied by the common factor 5. That's really where the word factor is coming from. Now, if x is 3, it's 5 times 5 to the power 3. Again, I multiplied by 5. So it's a very different scenario between linear and exponential. So in the exponential function, when x increases by 1, what happened to the y value? Who would like to finish my sentence? Look at this picture. What happened to the y value? X increased by 1. The y value is doing what? You're very quiet today. Usually you're more talkative. What happened to the y value?
Wait, I'm sorry. Did you say the y value increased or decreased?
I didn't say anything. When x increases by 1, the y value is, finish my sentence.
Being multiplied by 5.
It's multiplied by 5. I didn't say it increase. In this case, it will increase because it's multiplied by 5. It's going to increase, that's for sure. Because you're multiplying it by a huge number. So it's multiplied by 5. Okay, I'll take one more scenario and then we actually come up with this. So is it going to increase? Yes, because the y value you multiplied by a huge number, which is 5. So of course it's going to increase. So in general, this is the rule for exponential. I mean, it's based totally on that. If f of x is exponential, means a times b to the x. So the growth factor is b. Is b. Then when x means the input increases by 1 in an exponential function, the y value, if you want, or the output, but I said the y value to make it very clear, the y value is multiplied by b. Okay, in the linear growth, if x increases by 1, the y value is increases. It's not multiplied. In the y value, every time we add the slope. In a exponential growth, when x increases by 1, the y value is always multiplied by the same number. So this is actually our picture in general. If this is x, and this is f of x, a times b to the x. 0, 1, 2, 3. That's our picture. This is a. This is a times b. Means we increase by 1, we multiply by b. Increase by 1. This is a b squared. From here to here, we're multiplying by b. So we multiply by the same. And this is a b cubed, means I am multiplying by b. Okay, that's really the behavior of a exponential. So we multiply by the common factor b, that's why factor coming from. In the linear, we add the same number, which is the slope. So I've analyzed this with the following simple example. So I'm going to give you a function, one linear, one exponential, and I'm going to ask you to find a certain k. So my problem is the following. Okay. Find k. Okay, find k. All right. Suppose I have a function of, so a, I have a function f of x. F of x, and this is 1, 2, 3, and this is 2, 4k. That's my function. I didn't tell you anything about my function yet. I'm going to graph it, though, just to give you an idea. So this is 1, 2. That's a point. And this is 2, 4. And this is the graph. So now I'm giving you the graph. It means I'm telling you already something about the function. So this is 2, 4. And this is 1, 2. So 3k should be somewhere here. Okay. What's k? Quickly. So I gave you the graph. Means you should see immediately linearity. So what's the k in this scenario without finding a formula for the function, just by analyzing the problem. What's k? Absolutely 6. We're adding 1. We add 1. Because it's linear, we're adding +2 in here. So from here to here, we have to add +2. So my k is going to be what it was, +2, which is equal to 6. So we're not finding formulas here. We're just trying to interact better with the situation. So we increase by 1. This is go up by 2. Another 1, and another 2. So I get the k equal to 6. Now, I'm going to give you the same data, but the function is not linear, it's exponential. And the same question. So B, the same data, x, f of x. Again, we have 1, 2, 3, 2, 4, k. Okay, this is the data. But the graph this time is exponential. It means this is 1, 2. These are the point. And 2, 4. But the graph is not linear, so I don't know how the graph is an exponential graph. That's exponential. And so I know this is 2, 4 here. And this is 1, 2. And the question is, without finding the formula, that's the idea in those particular problem, without finding the formula, I want you to give me k. And the idea is to understand how does exponential function work. Okay, give you a minute to do that. Eight. You agree with Grace? X increases by 1, x increase by 1. If it's exponential, it means the y should be multiplied by the same number. So from here to here, we're multiplying by 2. So from here to here, we need to multiply by 2. So this is going to give me that k is 2 times the 4, which is equal to 8. So on the picture is, since exponential, it means from here to here, we multiply by 2. That's the 4. It means from here to here, also we multiply by 2. So 4 times 2, k is equal to 8. So if I have a table of value, that's really what's happening in exponential versus a linear growth. So next time we basically will wrap up exponential, and what we're going to talk a little bit more, we're going to do more problem along those lines, and we start graphing those functions so we understand them fully. And once we're done with that, we're going to start with the last idea in this course, which is the logarithm function. But we worry about that next time. All right, so the class is done. If anybody has any questions, please let me know. Make sure to do the practice problems. Even if you think you understood, you have to do the practice problem because they involve algebra that you mess up with.